Hello everyone, my name is Arisa Kohtani from Tokyo Institute of Technology. I'll be presenting a paper titled MOSion, Gaze Guidance with Motion-Triggered Visual Cues by Mosaic Patterns. The public advertisement is looked at by pedestrians and stopping observers. For moving observers, it is desirable to induce them to stop to look at the intended area by the guidance, while the other stopping observers who see the advertisement should not be disturbed. Therefore, we require a method that provides a gaze guidance effect for moving observers without disturbing the perception of stopping observers. To guide the gaze, some studies utilize digital image processing. Some studies have proposed systems to guide observers' gaze. The first is the gaze guidance method by enhancing saliency by changing the saturation and luminance. The second is the gaze guidance by making slight changes to the human peripheral vision. These studies are effective in gaze guidance, but they require image change or eye tracking devices. One method that does not require eye tracking is to change the image depending on motion state. Light integration in MOSion makes it possible to change the image depending on the speed and direction of motion as shown in this slide. These studies use light integration and the afterimage effect over a certain time period. However, these studies cannot accommodate irregular motion due to the restrictions. To address these problems, we propose a new gaze guidance method called MOSion. MOSion meets the following three requirements. Firstly, it provides gaze guidance only in motion, allowing the stopping observer to see the original image. Also, no eye tracking device is required. Furthermore, there are less constraints by motion, and it can accommodate irregular human movement. To meet these requirements, we suggest a concept that saliency will be enhanced only in moving conditions. Saliency is a measure of how well an area discriminates against its surroundings. In this study, in order to guide the gaze, a part of the image is changed into mosaics to enhance saliency. MOSion allows the users to guide the gaze while walking and then turn off the gaze guidance effect when stopping. It is possible to guide the gaze without disturbing the observation of the image. To realize this concept, we utilize light integration. In common projectors and displays, the pixel values are generated by combining three colors of lights: red, green, and blue. If we switch between red, green, and blue at high speed, these three colors appear as a single image by light integration. For example, if pure red, green, and blue color images are projected at short intervals, human vision perceives the color as white, and the magenta color is perceived when only red and blue colors are projected. Thus, various colors can be achieved by superimposing RGB. Using this principle, we decompose a single image into 4 mosaic images. The mosaic patterns contain tiled RGB and black squares. These 4 mosaic images are added together to form the original image, shifting the colors over time. In stopping condition, the mosaic patterns of 4 images are correctly integrated in the human vision, and the original image is perceived. In contrast, the moving observers perceive an image with a part of mosaics added to the original image. This allows the user to see the highly salient visual cues and guide the gaze in moving condition. The following is a system overview of MOSion. First, a designer inputs an image and selects the target area to improve the saliency. Next, MOSion generates the decomposed images containing mosaics. Then, decomposed images are cyclically projected at a high-speed projector. These steps complete the MOSion. The result is projected like this. In this example, we are trying to guide the gaze to the fish within the red frame. The effect is not visible in stopping condition, whereas the mosaics at the fish is visible in moving condition. MOSion can also be applied to posters containing text. As in the previous example, the mosaics are visible in moving condition, while the effect disappears in stopping condition. To evaluate whether MOSion has the capability of controlling the saliency, we conducted two evaluations. First evaluation is conducted to verify how much MOSion increased the image saliency of the decomposed images. Second evaluation was conducted to verify how are the mosaic patterns displayed by high-speed projection while working as an example of moving conditions. Firstly, I'll show the evaluation result of how MOSion has the capability of controlling saliency in experimental conditions. As shown in these figures, the saliency around the mosaic patterns is enhanced compared to the original image. These evaluations suggest that color decomposition of MOSion creates color boundaries and improves saliency. Secondly, I'll show the evaluation result of how the mosaics are displayed in the experimental environment. As shown in these figures, the images remain similar to the original image in stopping conditions, whereas mosaic patterns are visible in moving conditions. The saliency around the mosaic patterns is enhanced. These evaluations suggest that MOSion improves the saliency in moving conditions. Next, we conducted a user study to investigate how MOSion affects users' perceptions in different moving conditions. 22 people participated in this experiment. We verified the following three hypotheses in this experiment. The first is, MOSion enhances gaze guidance effect during walking. The second is, the gaze guidance effect varies depending on the observer's movement. The third is, the gaze guidance effect varies depending on blinking. I described the experimental design. First, participants observed an image while walking and then answered the points to which they directed their attention in the image. Participants then stopped in front of the projector to answer questions about the difference in vision between walking and stopping. They also answered questions about the difference between blinking and not blinking. These questions were asked using a Likert scale. These scenarios were repeated 8 times. The participants were not informed whether the method was applied to the image or not. Finally, an after-task questionnaire and interviews were conducted to gather feedback on the image perceptions. This slide shows the result of user study. These figures show the correctness of participants' focus points. For all images, the correctness of focus points were significantly higher for the MOSion condition than for the unaltered condition. These results indicate that our method demonstrated the ability to guide gaze during walking. Here is the example gaze data of the participant, who reported focusing on the intended target with MOSion. As shown by the red circles in the data, the gaze is actually directed toward the intended fish. We also compared the result of moving differences. As shown in the left figures, the changes were observed between walking and stopping except for the scenery image. As shown in the right figures, the changes were observed between blinking and not blinking except for the city image. These results show that gaze guidance can affect varies depending on the observer's movement or blinking. Next, we show the results of the questions asked after the task. We asked how the projection results see for each of the 3 movements in the experiment: walking, stopping, and blinking. In walking condition, participants stated it looked like noise with multiple colors mixed. In stopping, they mentioned it appeared as normal. In blinking, they stated it looked similar to when I was moving. We then collected the results of the interviews conducted at the end of the experiment. All participants noticed the abnormal of the projection. We then asked if a normal area coincided with the attention-grabbing area and asked why. As a result, 19 answered yes, 1 answered partially yes, and 3 answered no. Those who answered yes said it was because they were concerned about flickering. The results of the experiment are concluded as shown. The first hypothesis was accepted because the correctness of the participants' focus points was significantly higher for the MOSion in all images. The second hypothesis was partly accepted as the changes in the projection were observed except for the scenery image. Participants also mentioned noise-like changes with multiple colors mixed in. The third hypothesis was partly accepted as the changes in the projection were observed except for the city image. Participants also stated that it was similar to walking during blinking. Next, I'll show some concepts of applications in real-life situations. MOSion does not require any tracking device and can provide different vision to many observers of different movements. Therefore, it is suitable for gaze guidance in public places. Here, I'll show 3 application examples. The first is a poster presentation at a conference. By using white light with MOSion on an existing poster, we can make our point to a passing audience. The second is gaze guidance to vehicle advertisements. Our approach can promote the guidance effect not only by utilizing observers' movements, but also the passive motion such as a train. The third is to guide the gaze to 3D products. By applying MOSion to objects in shopping stores, it is possible to guide the gaze of passing customers to a specific product. Next, I'll discuss about MOSion. The results of the user study showed that several participants reported finding unintended flicker. Flicker can be reduced by selecting appropriate luminance, color conditions, and projection frequency. Next, other possible mosaic patterns for MOSion can be discussed. MOSion utilizes the edges of the mosaics to improve saliency, and mosaics of different shapes will have varying effects on saliency improvement. I'll conclude the presentation. We propose a gaze guiding method called MOSion that adjusts the strength depending on the observer's motion. Our method decomposes the target area into mosaic patterns to embed visual cues in the perceived images. MOSion enhances the saliency in the area in moving conditions and gives the adaptive gaze guiding effect. Thank you for listening. Please see the paper for further details.